Today we're actually taking equations and solving them, but since we only have one-step equations, the nice thing is that there's only one step. So, how do you solve a one-step equation? You want to isolate the variable using inverse operations. What does isolate mean? Tegan, what does isolate mean?
To take something else by itself.
To get it by itself. So we want to get the variable by itself. Okay, so we want to isolate the variable or get it by itself using inverse operations. Inverse means the opposite operation. Okay? And remember, whatever you do to one side, you must do to the other. Okay? Example 1. X plus 8 equals negative 10. Okay. X plus 8 equals negative 10. What is the variable in this problem?
X.
Good, X. My variable is X, and I want to get X by itself, which means I have to get rid of this positive 8. Now, my note said I need to use inverse operations, and inverse means the opposite. So, if this is a plus 8, and I want to get rid of it, what's the opposite of plus 8?
Negative 8.
Minus 8. So we're going to subtract 8 from that side, and whatever we do to one side, we do to the other, so we subtract 8 from the right-hand side as well. So what does that do? Let's look at it. What's positive 8 minus 8? 0. So they cancel each other out. That's what we want to happen. We want to get this guy to be 0. So then we have X by itself equals negative 10 minus 8. What's that going to give me? Very good. Negative 18. And that's your answer. Now, like good mathematicians, we should always check our answers. How would I check if that's the correct answer? Thank you, Matthew. Plug it in. So we're going to take negative 18 and plug it in for X. So negative 18 plus 8 equals negative 10. Is that a true statement? What's negative 18 plus 8? Negative 10. True statement. So we got the right answer. Okay? Example 2, a subtraction problem. X minus 4 equals negative 5. Okay, so this time I have X minus 4 equals negative 5, and I want to get rid of that minus 4. So what's the opposite of minus 4? Plus 4, so we're going to add 4 to both sides. Because whatever I do to one side, I have to do to the other. So what's negative 4 plus 4? 0, which is what we want. So we get X equals negative 5 plus 4. Negative 1. 5 is bigger than 4, and 5 is negative. So that's how we get our negative. Let's check it. I have negative 1 minus 4. What's negative 1 minus 4 going to give me? Negative 5. So it works. If it's an addition problem, we're going to subtract from both sides. If it's a subtraction problem, like example 2, we're going to add to both sides. We just do the opposite. Okay? So example 3. We have negative 3x equals 15. This one is a little trickier. Okay, negative 3x. How is this negative 3 attached to the x? Will you turn around to your neighbor and tell them how the negative 3 is attached to the x? Is it addition, subtraction, multiplication, or division? Okay, negative 3x is attached by multiplication. So what's the opposite of multiplication? Division. So we're going to divide both sides by negative 3. Okay, now I need everybody to think about this really quickly. What is negative 3 divided by negative 3?
1.
1. It's 1. It's not 0. So these aren't canceling each other out this time. They're reducing to 1. Okay, so when we're multiplying or dividing, we're actually reducing it to 1. And what did I tell you about a 1 if it's in front of the x? It's still just an x. It's invisible, so we don't have to write it. Okay, so it's not a 0x, it's a 1x. Equals 15 divided by negative 3. Negative 5. Okay, make sure you check that. So that's negative 3 times negative 5. A negative times a negative gives me a positive what? 15. So we got the right answer. Example 4. Four-fifths x equals 8. Look at this 4/5, guys. Is that attached by addition, subtraction, multiplication, or division? Multiplication, okay? So I want to turn this 4/5 into a 1. Look up at the inverse property poster. What do I multiply by to get an answer of a 1? Nate, will you say it louder? The reciprocal. So when you have a fraction, what we want to do is multiply by the reciprocal. What's the reciprocal here? 5 over 4. So multiply both sides by 5 over 4. Okay, and then let's think about it. How many of you are comfortable with cross-reducing? Okay, we will get into that in just a second then. Let's just multiply straight across for right now. What's 5 times 4? 20 over, what's 4 times 5? 20. X equals, this is the same as 8 over 1. What's 8 times 5? 40. 1 times 4? 4. Okay, let's reduce this. 20 over 20 reduces to? 1. So this is just a 1x equals, what does 40 over 4 reduce to? 10. So my answer here is 10. Okay? Let me show you a trick. We multiplied 5 times 4 and 4 times 5, right? But let's look at the cross. We're not doing cross products, we're doing cross reducing. 5 over 5, what does that reduce to? 1. What about 4 over 4? 1. So what would I be left with? A 1x, right? Let's look at this part right here. Does 1 and 5 reduce at all? No, but what about 4 and 8? Yeah, 4 goes into 8 how many times? 2. So what's 2 times 5? 10. So you can reduce it before we actually do the multiplying. Just so that for when you see it on your homework. Okay. So example 5. Let's do x over 3 equals 7. Okay, so we're going to make up an example 5. X over 3 equals 7. Okay, this is a fraction also, but since it's just an x over 3, what operation is that? Division. So what's the opposite of division? Multiplication. So I'm going to multiply both sides by 3. Why? Because what's 3 divided by 3? 1. So they reduce. So that's going to give me x equals 21. And then a quick check. 21 over 3. What's 21 divided by 3? 7. Okay? So that is when we have just division. So if we have, like in example 3, multiplication, we divide on both sides to get your answer. If, like in example 2 or 4, you have a fraction, we multiply by the reciprocal, and that's going to give us our answer. And if, like in example 5, we have a division, we multiply to get our answer. So you always just do the opposite. Okay?